So what are the benefits of using microservices architecture? When we use microservices architecture, because every microservice is like a mini application and it is completely autonomous and independent, we can deploy them independently. So if we need to make a change in part of the system, we only make that change in the relevant microservice, and then we only deploy that microservice. We don't need to deploy the entire system. Microservices also can be scaled out independently. When we say scale out, it means that we will have more instances of a given service. For example, say you have a system made of payment microservice and then product microservice and then shopping cart microservice. So when users come to this website, all of them will need to pull the products from the database and see them, but only a percentage of those people will add some products to the shopping cart, and only a fewer people will actually go to payment and buy the products. So if we get, for example, 1 million users a week who come to the website and they visit the products, we need to scale out the microservice that is for displaying the products, for pulling the products from the database and provide them to the website. But we don't need to scale out the payment because only a small percentage of people probably finish the checkout and go and pay. So for that reason, microservices can be very useful because we only scale out the required microservices. Microservices also offer better fault tolerance, and that is again due to the fact that every microservice is independent. There is a concept called blast radius that we will see later. So when we manage the blast radius properly, if a microservice fails, the other microservices will still manage to do work, maybe not ideally, but then they will still be able to do the job to some extent, and then the entire system won't crash. And because every microservice is small compared to a large monolithic application, and because normally one team looks after one or a handful of microservices, when a new person joins the team, it's easier for them to understand the code and get a hang of it. And also different microservices can be built with different technology stacks. We talked about this. So one microservice can be like .NET, another microservice might be built with Python, and that gives you flexibility in choosing developers and creating teams. And also microservices can communicate asynchronously. When we say microservices communicate asynchronously, it means that they don't call each other's API directly. There is no point-to-point API call. So for example, we have service A, which needs to communicate with service B and service C. If service A wanted to make a call directly to service B, then service A would be dependent on service B. There would be a coupling or dependency there. So to remove this situation, normally we have something like an event streaming system in place. For example, Kafka is one of them, or you can have a message bus, something like ActiveMQ or RabbitMQ. We will see them in more details later. I just want to explain the latest point here very quickly. So in case in an interview you get asked that, what do you mean by that? You can have an example. So service A, to avoid making a direct API call to service B and service C, publishes an event to the event stream. For example, if service A is responsible for signing up new users, when a new user is created, it just publishes an event, which is, imagine like a piece of JSON document with some properties, to the event streams. And service A doesn't care who is going to receive this event. They just say, hey, this event happened. Now, anybody who is interested in that service, for example, service B and service C, they subscribe to the event stream and they pull this stream from the event stream. So event stream is not pushing it to the service B or service C. It is the other way around. Service C and service B pull it from the event stream. Again, if we had something like service D and it was also interested in user created event, they could subscribe to the event stream and pull that. And as you see, in this case, service B and C, they don't care who is sending that event. Even you can have like another service that raises the same event. They just get the event and consume it and do something about it. And also service A doesn't care who is going to receive that event. So as you see, there is no dependency between service A and service B, and also service A and service C. And that is a huge benefit of using microservices in this style.